This is a continuation of our Module 2 in Structural Theory 1. Let me demonstrate how to solve another 3 examples. I will answer problem number 2, problem number 3, and problem number 7. So the statement in problem number 2 said, the floor system of an apartment of a 100 mm thick reinforced concrete slab resting on 3 steel floor beams, which in turn are supported by 2 girders. So the figure is here. The areas of cross-sectional areas of steel floor beam and girders are respectively 11,800 mm square for beams and 21,100 mm square for girders. Find the dead loads of the floor beam CD in girder AD. So we have the table at the back for unit weight of construction materials. So let us analyze CD or girder CD, floor beam CD rather. First, gather the given. What's given? For concrete slab, the unit weight is 23.6 kilonewton per cubic meter. And for steel beam, 77 kilonewton per cubic meter. Ito sa table. Thickness of slab, 100 millimeter. Okay, back to the figure. So the tributary area assigned to the beam CD is this shaded square. The span between beams is 3.6 meter. So bisecting the area of the floor to assign to the floor beam, it will give you 1.8 here and 1.8 here. So total of 3.6. Length of 7.5. So that is tributary area. So draw the free body diagram. This is point C, point D, supported by girder, both end, length of 7.5 meter. This will be its distributed load. Represent it small w. So the small w is equivalent to self-weight of steel beam plus weight of concrete slab. Okay, so using the unit weight 77.0 kilonewton per cubic meter multiplied by, so the given area is in millimeter square, 11,800 millimeter square. So per 1,000 millimeter we have 1 meter. So in order to convert it to meter square, because we have cubic meter here, 11,800 millimeter divided to 10 to the 6 millimeter square to be meter square. Because for every 1 meter there is 1,000 millimeter square, both numerator and denominator. So it will give you in the denominator 1 million. So 10 to the 6 plus concrete, weight of concrete slab 23.6 kilonewton per cubic meter multiplied by width width of tributary area, that is 3.6 meter, multiplied by thickness of slab, that is 0.1 meter. So it will give you equals, using your calculator, 9.40 kilonewton per meter. Computing for PC and PD, summation of force vertical equals 0. Knowing that PC is equals to PD because it is symmetrical, so yung 2P is equivalent to W multiplied by length, that is P is equals 9.40 kilonewton per meter multiplied by 7.5 meter over 2. Then the value of PC will be value of PD will be 35.25 kilonewton. Okay. So for girder AE. For girder AE, draw the free body diagram of girder AE. This will be point A, this will be point C, and this will be point E, supported by column. So this is reaction A, reaction E. The length is 7.2 meter. This one. This is the length, 7.2. So we already get the concentrated load here, 35.25. So you have to analyze the beam AB in order to get the concentrated load here and concentrated load and point E. Okay. For beam AB, so half of the floor, this is the tributary area. The width is 1.8 and the length is 7.5. This is PA and PB. 7.5 of length. This will be the concentrated or distributed load. So yung W small is weight of concrete, 23.6 kilonewton per cubic meter, multiplied by 0.1 thickness of slab meter, multiplied by yung width ng tributary area, 1.8 meter, plus 77 weight of steel beam kilonewton per cubic meter, having the 11,800 over 100 multiplied by 10 to the 6 in order to be meter square. So distributed load is 5.16 kilonewton per meter. Solving for PA equals PB. Symmetrical also will be 5.16 kilonewton per meter multiplied by 7.5 over 2 equals 19.35 kilonewton. That is PA and PB. So here, this is concentrated load at point E is 19.35 kilonewton. Concentrated load in point A is 19.35 kilonewton. So what is the uniform dead load of girder AE? So uniform is equals weight of girder alone. kilonewton per cubic meter multiplied by its cross-sectional area that is 21,100 over 10 to the 6 meter square. It will give you 1.62 kilonewton per meter. So solving for RA, because it is symmetrical, RA is equals to RE, which is equals 3 concentrated load, that is 19.35 plus 19.35 plus 35.25 plus uniform load na 1.62 kilonewton per meter multiplied by 7.2 meter length of girder all over 2. RA is equals RE. It will give you almost 43 kilonewton. Round off na po yun. Okay, number 2. Number 2, solve problem number 2. Number 3 rather. Solve problem number 2. If 150 mm thick brick wall, which is 2.1 meter high and 7.5 meter long, bursts directly on the top of the beam. So we refer to the same figure here. So yun daw, brick wall na may taas na 2.1 at may length na 7.5 also ay directly na nakapatong dito. So may dingding doon. No? The same. Pinakuha sa atin yung dead load along beam CD. Okay. So I draw the ayan, isometric view. So ito yun. Ito yung brick wall. Ito yung slab having the thickness of 100 mm thick. Ang thickness ng brick wall ay 150 mm. Ang height is 2.1. So ito yung tatlong steel beam. At ito yung girder sa ilalim. Okay. So draw the free body diagram of beam CD. This is PC. This is PD. This is 7.5 meter length. This will be the, let's say this is small W2 and another W. This is small W1. So this will be the distributed load contributed by the brick wall above the slab. Brick wall. And this will be what we have computed and problem number 2. Self-weight of steel plus concrete slab. So from problem number 2, we already solved the weight number 2. This is 9.40 kilonewton per meter. The brick wall for W1, this is unit weight of brick wall. So the brick wall will give you dun sa table ay 18.8 kilonewton per meter. 18.8 kilonewton per cubic meter. Multiply by, so this is along the length So in order to get the kilonewton per meter, you will multiply it by its height and thickness. So the thickness of 150 meter multiply by 2.1 meter. It will give you 5.93 kilonewton per meter. So the total distributed load along beam CD is equals 15.33 kilonewton per meter. 593 plus 940, that is 15.33. Then the load PC equals PB to get the supported reaction is equals 15.33 kilonewton per meter multiplied by length, which is 7.5 meter over 2. That will give you PC is equals PD, that is 57.47 kilonewton. So that's all. So for problem number 2, for beam AB and beam AF, it is similar to problem number 2. For beam AB and EF, what we get in problem number 2, we put it here the same. PA, PE. This is 7.5. What we get lately is equals to 5.16 kilonewton per meter. The computed PA and PE is equals 1935 kilonewton. So for the girder, AE, girder, BF. So we have the concentrated load here. This is 1935 for both A and F kilonewton. This is point A, this is point C, this is point E. This one will be what we computed PC. This is 57.47. So the reaction in the columns are reaction at A, reaction at E. RA is equals RE because it is symmetrical over 2. That's 19.35 plus 57.47 plus 1935 plus uniform load of girder, which we already computed. And problem number 2, what it is again? This is 1.62 kilonewton per meter. So plus 1.62 kilonewton per meter multiplied by 7.2. Length of girder 7.2. It will give us RA equals RE is equals 54 kilonewton. Okay, problem number 7. For the gymnasium whose floor system was described in problem number 4, determine the live loads acting on beam DF and girder AD. So what is stated in problem number 4? So problem number 4, it said the floor system of gymnasium consists of a 130 mm thick concrete slab resting on 4 steel beams. So given yung cross-sectional area that in turn supported by 2 steel girders having the given area. The figure is 2.3. Ito po yun. Determine the live load. So 7, determine the live loads acting on BF and AD. Acting on BF and AD. So this is BF and girder AD. Live load. So this is gymnasium. So from the table, we have the tabulation of assigned live loads. Ayan. Depends on the occupancy. So for gymnasium, ito siya. Dance halls and ballrooms, restaurants, gymnasium, 4.79 ang given. Ang unit, kilopascal. Kilopascal. Gymnasium. Live load is equals to 4.79 kilopascal, meaning this is 4.79 kilonewton and every square meter. So let us analyze the tributary area of beam BF. So draw na natin yung kanyang free body diagram. This is point B, this is point F. This is the reaction at PB, reaction at PF. Ang length sa figure ay 10 meter. Ang girder ay magkakaroon mamaya ng length na total na 15 meter. The tributary area, so bisect natin ang kalahati nito. Bisect yung kalahati dito, 3 at 5 meters. So therefore, the span of beam center to center is 5 meter. So this is 2.5, this is another 2.5. It will give us 5 by 10. Ayan, 5 by 10 tributary area. Ayon. Tributary area is equals 5 by 10. Okay. This is 10 meter span. This is the uniform load due to live load. This is live load. So the W, small w, would be live load assigned, that is 4.79 kilonewton per square meter. Multiply by 5 meter. And that's all. Using calculator, 4.729 multiplied by 5 is equals 23.95 kilonewton per meter. Ayun. So, along the uniform load, meaning along this length. That's why we multiply it to width, not the length. If you multiply it by length, you will get the wrong answer. So that's all. The what is PB and what is PF. Due to symmetry, this is 23.95 kilonewton per meter multiplied by 10 meter over 2 the reaction is PB/PF is equals 23.95 multiplied by 10 over 2 is equals 119.75 kilonewton. Okay, let's proceed to the edge beam. So you call it edge beam, and the center beam, edge. Sabi sa problem, ito lang daw ang kunin natin at saka ito. But because kukunin natin ang concentrated load dito, tsaka dito, at saka dito, we are required to solve the loadings assigned in edge beam, live load. So, edge beam, AE and DH. Free body diagram. Okay, so be smart. Yung PE over and PA, because the tributary area will be half what we get from beam BF. The reaction will be half of 119.75. 119.75 over 2, that is 59,875. 59,875. But let us prove. Small w here is equals 23 of 4.79. That is the assigned live load, kilonewton per square meter. The width of tributary area is 2.5 by 10. So multiply it by 2.5 meter equals 4.79 times 2.5, 11,975 kilonewton per meter. So getting the reaction, or PA equals PE is equals 11,975 kilonewton per meter multiplied by 10 meter over 2. That is answer 59, half of the what we get from the center beam. So girder AD, girder EH. Point A, point B, point C, point D. This is the column, reaction at the column, and D, this is reaction of live load at the middle, 119.75. This is also 119.75, and for the edge, this is 11,975. 11,975 kilonewton. Total length, this is 15 meter. So due to symmetry, reaction at A and reaction at D is equals. So therefore, to reaction is equals 11,975, dalawa yon, plus 119.75, dalawa din yon, then over 2. Reaction at RA equals reaction at RD, which is equals 179.63, which is almost 180 kilonewton, and that is the answer. So ba't hindi kinuha yung ano? So iba yung usapan natin sa dead load at saka sa live load. So sa analysis ng structural framing, hindi laging magkikita kayo ng symmetrical. So, lahat nung ginawa natin dito na example ay symmetrical, kaya ang reaction laging over 2 lang. Pero hindi gayon palagi. Baka naman sabihin nyo, laging over 2, kaya lahat na lang kahit hindi symmetrical ay over 2, mali kayo doon. Okay, that's all. I hope you will answer all of this. Pero, lahat ng solving problem na to sa laboratory activities, kahit sinagutan ko na yung 2, 3, and 7, isasama nyo pa rin po ito para masanay ang mga kamay ninyo sa pagsosolve. Marami pong salamat.